So AP Calculus first derivative test. Find all critical values. Find the open intervals on which f of x is increasing or decreasing. Let f of x equal x to the fifth minus 5x all over 5. So there was some difficulty on this problem because people weren't able to see what I think was kind of obvious, which is this. This is not a rational function at all. This has a constant multiplier here. So you can rewrite your f of x as f of x is equal to 1/5 x to the fifth power minus 5x over 5. Hopefully you can see the 5x over 5 here, and you can see the 1/5 times this here. Then if you differentiate, then f prime at x is equal to x to the fourth power minus 1. How did I get that? Because this is negative 1, right? 5 over 5 is 1, negative 1. So the first derivative of negative x is negative 1. Right? So we're going to do the first derivative test here. We're going to look for critical values. We know that this thing doesn't have any domain issues. It's defined for all x values of x. So we're going to set this equal to 0. So what we're looking for our critical values here is when is this true? So if we solve this, x to the fourth power minus 1 is equal to 0. Just some algebra here. We'll get x is equal to either positive or negative 1. That is to say, x is equal to 1 or x is equal to negative 1. That should enable us to set up our intervals. So I'm going to set up our intervals here. And the intervals are negative infinity, right? X is greater than negative infinity, but less than negative 1. Where did I get that negative 1? Got that negative 1 from here. And then I want the values between here and here, right? So the second interval will be x is greater than negative 1, but less than 1, right? That's this, right? And then we want everything to the left of this, right? So we want, I'm sorry, to the right of that. So we have x is greater than 1, but less than positive infinity. Hopefully that makes good sense. So those are our three intervals. And we want some test values. So I'm going to take test values here. So what number is in here? And negative 2 is certainly in here. What number is in here? Well, we could take 0 here. And if you're wondering how I'm choosing my values, I'm just picking a value that is somewhere in this interval. So negative 2 is less than negative 1, but greater than negative infinity. 0 is less than 1, but greater than negative 1. And here I'll take, I don't know, 2. Right? 2 is greater than 1, but less than positive infinity. And then when I want to assess f prime, I want the sign of f prime at the test value. So the sign of f prime at our test value. So f prime at negative 2 is equal to, right, is equal to 15. Isn't that right? Is equal to 15. And what conclusion can we draw? Well, 15 is positive, so our function on this interval is increasing. Take f prime at 0. F prime at 0 is negative 1, isn't it? Negative 1 is a negative number, so we know the function is decreasing on that interval. And lastly, we can assess f prime at 2, and f prime at 2 is also equal to 15, right? Because this is x to the fourth is 16, minus 1 is 15, is also 15, so we know it's increasing there, isn't it? So this should get us to this. Our function is answering the question. Alright, so in the problem we were asked to find the increasing and decreasing intervals. So here we have increasing here. So we have increasing on interval negative infinity to negative 1, right, in interval notation. And also we have it on this interval over here, don't we? We also have it on 1 to positive infinity, right? So, and then we know that in the in-between, that's where we have the decreasing interval. So it's decreasing from, oh, I'm sorry, it's decreasing on negative 1 to 0 and 0 to 1, right? we have let's find our relative maxes and mins. So what we're going to do is take these points, these critical values. We had -1. So what's f of -1? And f of -1, I just plugged it into the function, and f of -1 gave us the point -1 4/5, and f of 1 gave us 1 comma -4/5. So which is the max and which is the min? Well, this is the max right here, and this is the min here. All right, hope that was helpful. You guys keep it up. We're going to do a ton more of these problems. You're going to get great at it, so your feedback is appreciated.